Here is example 10 of solving trig equations. So here we have cosecant of 2 theta equals -2. So this is going to be pretty similar to example 9, but not quite as complicated. So the instructions are the same. Part A, find the general solutions. Part B, then after that, find the specific solutions in this interval 0 to 2 pi. And again, the way this is written, it just means 0 is less than or equal to theta, strictly less than 2 pi. Okay? Okay, so here the 2 inside of the cosecant is kind of complicating things just a little bit. And then also we have a cosecant, which we haven't had in trig equations before. But to handle that, we just have to convert to sine. In general, sines and cosines, but cosecant is the same thing as the reciprocal of sine. So cosecant of 2 theta is actually 1 over the sine of 2 theta. Okay, and then that still equals -2. So now we can multiply the sine of 2 theta, or multiply both sides by the sine of 2 theta. So then on the left side we just get 1. On the right side we have -2 times the sine of 2 theta. Now we can divide everything by -2. So we have -1/2 equals the sine of 2 theta. Okay. Now where do we go from there? Well, let's come off to the side a little bit and think, okay, what if we just had sine of x? So let's come off to the side and look at that. Let's say we had sine of x equals -1/2. Then let's look at the unit circle between 0 and 2 pi. Do we have to be between 0 and 2 pi? No, for part A we really don't actually have to be between 0 and 2 pi, but it will make part B a little simpler if we stay between 0 and 2 pi. So let's go ahead and draw our unit circle, x-axis, y-axis, big ol' unit circle. Okay, so if sine of x is -1/2, this is actually, this corresponds to a nice angle, nice special values on the unit circle. So we know that if sine of x equals -1/2, then x equals 7 pi over 6 or 11 pi over 6. Okay, so here's 7 pi over 6, and then here is 11 pi over 6. Okay, so if sine of x is -1/2, then x is 7 pi over 6, or x equals 11 pi over 6. Okay. So here, sine of a thing equals -1/2, so that thing equals 7 pi over 6, or that thing equals 11 pi over 6. Well, if we come back over here, we don't have x, we have 2 theta, but the same exact principle applies. Okay, so let's come over here then. Sine of 2 theta equals -1/2. Okay, so keeping the same principle in mind, then what that tells us is that 2 theta equals 7 pi over 6, or 2 theta equals 11 pi over 6. Okay? So here, whatever's inside of this, so we're taking sine of something that equals -1/2, so whatever's inside of the sine equals 7 pi over 6 or 11 pi over 6. Okay? So here we have 2 theta. Okay, now again, just like in example 9, you might be tempted to divide everything by 2 and then do the plus 2k pi thing, okay? And it is going to be 2k pi because cosecant, okay, the original function was cosecant, and the cosecant function has period 2 pi. So we are going to eventually add a 2k pi, but where do we do it? Well, just like in example 9 in the previous video, we have to be careful. Now here, what do we have going on? Well, here we would just, for the general solution in this case, we would have x equals 7 pi over 6 plus 2k pi, where k is any integer. And we would also have x equals 11 pi over 6 plus 2k pi, where k is any integer. Okay? And from now on in this video, we're going to stop writing k any integer just to save time and space. So now the point is, it's not that it's just x, the point is it's what's inside of the sign. Okay? So here the x was inside of the sign, so the x is what we add the 2k pi to. Now over here, the 2 theta was inside of the sign. So 2 theta is what we add the 2k pi to. So 7 pi over 6 plus 2k pi, okay, or 2 theta equals 11 pi over 6 plus 2k pi. Okay, so again, the 2 theta is what's inside of the sine function here. So whatever's inside of the sine, take that entire expression inside of the sine function, in this case just 2 theta, and then we add 2k pi to that. Okay, that's how we do it. Add 2k pi first, then get theta by itself. Okay, first add the 2k pi, then isolate the theta. And again, we're adding 2k pi because it's cosecant, and cosecant has period 2 pi. Okay, now we can divide everything by 2 and simplify. So let's erase this because we're kind of out of room. Okay, so if 2 theta is 7 pi over 6 plus 2k pi, theta is 7 pi over 6 plus 2k pi. If we divide everything by 2, then we have 7 pi over 6 divided by 2 is 7 pi over 6 times 1/2, which is the same thing as 7 pi over 12. So this is going to be 7 pi over 12 plus what? Well, 2k pi, if you divide that by 2, the 2's cancel, that's great, we're just left with k pi. Okay, let's erase these. Similarly, if we take 11, so 2 theta equals 11 pi over 6 plus 2k pi. If we divide everything by 2 here, then what we get is theta equals 11 pi over 12. Okay, because remember, dividing by 2, it's like multiplying by a half. So 11 pi over 6 times 1 over 2 gives us 11 pi over 12. And then plus 2k pi over 2, which is just k pi. Okay. So these are the answers for part A. Okay, these are the general solutions here, where k is any integer. So for the final solution, I guess we should write that. So k any integer, k any integer. Okay. Okay, so that's our final solution for part A. All right, now part B, find all the solutions in this interval 0 to 2 pi. So we're going to do exactly what we did in the previous video. We're going to set up a little chart here. But before that, we want to get a common denominator just to make it a little bit easier. So let's clear some room here. Okay, so what's our common denominator? Well, it's just going to be 12, right? So to get a common denominator, 7 pi over 12 plus k pi. So pretty straightforward, just multiply this by 12 over 12. So this is 7 pi plus 12 k pi, all divided by 12. Okay. Similarly, this 11 pi over 12 plus k pi, multiply by 12 over 12. And then that's pretty much it, 11 pi plus 12k pi, all over 12. Okay, so these two things right here, these are the general solutions with common denominators. So let's go ahead and set up our chart. So we're going to have k, and we have our first general solution, 7 pi plus 12k pi, all over 12. And then our second general solution, 11 pi plus 12k pi, all over 12. Okay, now we're just going to plug in the specific values of k. So let's start with k equals 0. Okay, so we'll zoom back out a little bit here. Now if k is 0, what happens? Well, if k is 0, then we just have, 7 pi over 12 and 11 pi over 12, right? So if k is 0, this whole part gets wiped out, 7 pi over 12, and then 11 pi over 12 is all that's left over. So 7 pi over 12, 11 pi over 12. Now, how do we know when to stop? Well, we know we want to stop when we hit 2 pi, but we're getting answers over 12 here, right? So what's 2 pi expressed as something over 12? Well, just multiply by 12 over 12, and then that's going to be 0 less than or equal to theta less than 24 pi over 12. So once we get 24 pi over 12 or larger, then we know it's time to stop. Okay, we aren't there yet. 7 pi over 12, 11 pi over 12, what's next? Well, if k is 1, then we have 7 pi over 12, or sorry, 7 pi plus 12 times 1 times pi, so 12 pi all over 12. 7 pi plus 12 pi is 19 pi, so we have 19 pi divided by 12. Now what if we do it down here? 11 pi plus 12 times 1 times pi. 11 pi plus 12 pi is 23 pi, all divided by 12. Okay? So remember, we're trying to hit 24 pi over 12. We're almost there. Really, 23 pi over 12, you could safely assume it's, well, I guess we don't really want to assume anything in general here, but let's just go ahead and do the next one. So, you know, it is pretty close, so we might think the next one's going to be too large, and in fact, it turns out to be the case. So 7 pi over 12, or sorry, 7 pi plus 12 times 2 times pi, so that's 24 pi, all over 12. Well, 7 pi plus 24 pi is 31 pi, so this is 31 pi, all over 12. Too large, okay, so that's not part of our solution for part B, because we only want values inside of this interval 0 to 2 pi. Now, if we were to do it again here, we would have 11 pi plus 24 pi, which is 35 pi, and that'd still be divided by 12, okay? Remember, k is 2, so 12 times 2 times pi is 24 pi. Add the 11 pi, we get 35 pi, and we're dividing by 12. Okay, so we just have these 4 right here. Now what about, so we know now we have values too large. What if we go the other way? So let's say, what if k is -1? Well, if k is -1, then what do we have? We have 7 pi minus 12 pi, so it becomes 12 times -1 times pi, which is -12 pi. 7 pi minus 12 pi is -5 pi. So this becomes -5 pi over 12. Okay, too small. It's not inside of this interval from 0 to 2 pi. What about over here? 11 pi plus -12 pi. Okay, 12 times -1 times pi, that's -12 pi. So 11 pi minus 12 pi is -1 pi. So we have -pi over 12. Also outside of the interval from 0 to 2 pi. So the only solutions for part B then are these 4 right here. And we might expect 4 because normally there would be 2 solutions for a cosecant because it's reciprocal to sine, but we have a 2 inside of here, so 2 times 2 gives us 4, so 4 total solutions. 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12 are the 4 specific solutions inside of this interval 0 to 2 pi. Okay, so that's example 10 of solving trig equations. And here are our specific solutions, and here are the general solutions again.